Okay, so we're going to have an alcohols quiz now, then, guys. So what you'll need here is your alcohols poster in front of you. And I'm going to ask you 10 questions based on the information on that poster. I'll pause or I'll ask you to pause in between each question so that you can get some thinking time. Right, ready? Question number one on our alcohols quiz. Okay, which of the following would be classified as a secondary alcohol? Okay, so we subdivide alcohols into primary, secondary, and tertiary alcohols, depending on how many carbons are attached to the COH. So which of these would be regarded as a secondary alcohol? So pause the video now and I'll come back with the answer in a second. Okay, so you looked at your poster. Did you check out which one is the secondary alcohol? If you were right, then you would have come up with the answer of A is our secondary alcohol. Because here to this carbon, this is the key carbon, we've got two other carbons attached, and that would regard it as a secondary alcohol. So we use this little weird symbol, secondary. This one here, it's only got one carbon attached onto the COH, so that would be a primary alcohol. And this one here has got three carbons attached to the COH, so that would be a tertiary alcohol. Okay, so question number two. What is the missing reagent in this laboratory formation of methanol? Okay, so if we were to form methanol in the laboratory, we might react sodium hydroxide in water under reflux conditions with a certain reagent. You'd form methanol and you'd also form sodium iodide. So what's this missing reagent here? Pause the video now and I'll come back with the right answer. Okay, a little bit sneaky of me here because this is actually a throwback from our halogenoalkanes poster, but we're making an alcohol, so it's legitimate of me asking you it here, really, because we're making an alcohol. So the halogenoalkane, in this case, we'd need one carbon in it, so it would be CH3, and we'd need to attach that to a halogen so that we could swap it for an OH, and in this case, the halogen must have been iodo. Iodomethane would have been our missing reagent here. So very important that you try and make connections between these posters, because that's what an examiner will try and do when they examine you next year, possibly. So this is a link between halogenoalkanes and alcohols. Okay, so question number 3 on our alcohols quiz. What would be the name of the organic product formed in this reaction? What would be the organic product formed here? So we've got propantuol being heated with aluminium oxide. Okay, what's the organic product formed here? Pause the video now and I'll come back with the right answer. Right, did you spot this one? What we're looking to do here is to do a dehydration. We're looking to get rid of water from this molecule. This is what the aluminium oxide is going to do. And if you get rid of water, then these two carbons are going to be a bond down, so they're going to get over that by bonding together. We're going to make an alkene. That's what our alkene will look like. But it's asking for the name. So did you name it? Prop. I suppose it should be prop-1-ene, but with propene, you can't get prop-2-ene, so propene would be fine. Prop-1-ene would be the ideal name. Okay, question number 4. What colour change would be seen in this reaction? What colour change would we be seeing in this reaction? So we have here ethanol being refluxed with potassium dichromate in acid to give us ethanoic acid. Potassium dichromate is itself reduced to chromium 3, whereas the ethanol is oxidized to ethanoic acid. So what colour change would we see here? So Pause the video and we'll come back with the right answer in a second. Right, did you get it? Did you find it on your poster? If you did so, you would have seen that this is orange in color, and this is like a, well, it's kind of a bluey green, but I suppose it's more green than it is blue, a bit turquoisey type of color. The ethanol has no color, the ethanoic acid has no color. The only way we know this reaction is happening is by the reduction of our potassium dichromate, an orange to green. And it's often used as a test to identify alcohols or aldehydes. Okay, question number 5. What type of reaction is the following? How would you classify this type of reaction? So what we've got here is we've got ethene reacting with water, and we've got phosphoric acid acting as a catalyst here under quite forceful conditions, 300 degrees C on 60 atmospheres, to give us ethanol. This is the industrial formation of ethanol, in fact. But what type of reaction is going on here? Have a look at your poster and pause the video now to see what the answer, or try to think what the answer would be. Okay, did you find that section in your poster? If you did, then you would see hopefully that it is an addition reaction. We are adding water across this alkene. Remember, most reactions of alkenes are addition reactions. And so our water here, there you can see the water's been added to the alkene over here. So we no longer have an alkene, but we have an alcohol. And it's an addition process. Right, where are we? Question number 6 coming up. Can you name the missing organic starting material here? Okay, so we've got potassium dichromate, or sodium dichromate, or dichromate ion anyway, in acid under reflux conditions. And we are making this molecule here, which is methylpropute butanone. This is an example of a ketone, butan 2-one. It's a ketone. Okay, but what would we use to start with to make this ketone? Pause the video and we'll come back to the right answer. Okay, did you find this in your poster? What we've got here, to make a ketone, we need to oxidize a secondary alcohol. So there's the OH. So there's where the OH was. So we need the OH here. And the rest should all be hydrogens. But we have to name it, remember? We're asking for it, to name it, not just to draw it. So what we've got here then is butan 2-ol. So oxidizing butan 2-ol, potassium dichromate in acid, under reflux conditions, will oxidize it to butan 2-one, the ketone. Right, question number 7. Hopefully you're doing really well. Let's see if we can get this. Question number 7. Okay. Ethanol can be formed during the fermentation of carbohydrates. Can you balance the equation for this fermentation process? So here's our carbohydrates. Here's our ethanol. We also make CO2 in the process. We need to balance this form of the equation. Pause the video, have a think, and then see if you got the right answer. Okay, if you balance this correctly, we have 6 carbons here. We only have 3 here though. But if we double this up, and we double this up, and that brings us to 4, 5, 6 carbons there. 6 hydrogens here, but we've doubled them all up. So that brings us to 12. And then 4 oxygens here, and the 2 here bring us to 6. So it's C6H12O6, giving you 2 ethanols and 2 CO2s. That was the balanced equation for the fermentation of carbohydrates. Right, question number 8. Ooh, big one here. Ethanol can be oxidized to ethanal, over here, reaction A, or it can also be oxidized to ethanoic acid. Reaction B. Which separation technique can be used to promote reaction A instead of reaction B? So if we wanted to form ethanol, not ethanoic acid, we would oxidize our we want to form ethanol and not ethanoic acid. We would oxidize our ethanol with potassium dichromate. It's the same reactant for both of these. Same reaction in all intents and purposes, but this one is a bit more extreme than this one. We would use a separation technique to ensure that our ethanol gets separated from the mixture before it forms ethanoic acid. So what separation technique might we use to do that? Pause the video, have a look at your poster, see if you can find the answer. Right, do we get it? It is in fact distillation. Because the ethanol has a lower boiling point than ethanol, or indeed ethanoic acid, we can remove it from the mixture by distillation to stop it from becoming ethanoic acid. So it's distillation that would allow you to form an aldehyde rather than a carboxylic acid. Okay, question number 9. We're almost there. 9 out of 10. How would you classify this reaction? Okay, so we've got ethanol being heated with aluminium oxide to give us ethene. How would we classify this reaction? Is it an addition reaction? Is it substitution? Or is it elimination? Pause the video and make your decision. Have you got it right? We've gotten rid of H2O here. So it is an example of an elimination. We've eliminated H2O. That might be a product somewhere along the line, but we've eliminated it. We've formed an alkene, and forming alkenes is very often an elimination process. Making alkenes, if we were going the other way, if we were adding the water, it would be an addition process. But because we've taken it away, it's referred to as an elimination. Right, and the last question in our quiz, question number 10. What product is formed when the following reaction is attempted? So we have here, what is this molecule? 2-methyl propan-2-ol. Okay, so this is 2-methyl propan-2-ol. And if we were to take potassium dichromate and acid and reflux this up, what product might we form? Pause the video, make your decision, see if you got it right. Right, bit of a trick question this one, because 2-methyl propan-2-ol is a tertiary alcohol. Now, primary alcohols can be oxidized with potassium dichromate to give us either aldehydes or carboxylic acids. Secondary alcohols can be oxidized with potassium dichromate to give us ketones. Tertiary alcohols cannot be oxidized. So this actually is a no reaction. Nothing will happen here. So a little bit of a sneaky question, that one from me. What product is formed? There is no product. Reaction doesn't occur. Right guys, 10 questions on alcohols. Hopefully you got 10 out of 10. If you didn't, find out where you went wrong and correct yourself.